in aqueous solution of ethanoic acid. Now it says in aqueous solution of ethanoic acid is gradually diluted. Which of the following statement is correct? Yeah, we did that. 11th question we did. So we have to do the 12th one, right? Now we have to do the 12th question. Methyl orange and phenolphthalein are both acid-base indicators. In the titration of strong acid against the weak alkali, so now see that it says in the titration of strong acid against weak alkali, right? So here now we are doing a titration. We are doing a titration. We are doing a titration. The titration of strong acid. The titration of strong acid, right? With the strong acid. We consider strong acid is HCl, right? Uh, in the titration of strong acid against the weak alkali, so the alkali is here weak alkali, we consider that is ammonium hydroxide. So this one, the strong acid against the weak alkali. The methyl orange is suitable indicator, but phenolphthalein is not. So we are going to find what are the suitable indicators for that. For that, we need to draw the pH curve. So we consider the pH curve. How we draw the pH curve? This one. For the x-axis, we take now volume of ammonium hydroxide. And for the y-axis, we take what? pH. Here the pH 0, here the pH 7, and here the pH 14. Right. Now, the HCl is there in the beginning. At the beginning, the very first second HCl is there. So HCl is having very low pH value, like close to 0 or 1. Now, therefore, most of time HCl pH value is very low. When the almost all the HCl is finished, the pH value will come suddenly to 7. And then ammonium hydroxide, now this is what is there, HCl. So now the next, after all HCl is finished, the next drop is ammonium hydroxide, which is a weak base. The weak base pH is around 8 or 9. So somewhere here will be 9 around. So now this is what the ammonium hydroxide, this is what the ammonium hydroxide. So they says that methyl orange is a suitable indicator, but phenolphthalein is not. We see that methyl orange pH range is 3 to 4. You can find it from the data booklet. Methyl orange is, I write MO for the methyl orange. Methyl orange is suitable because methyl orange is overlap with the quick pH change. If the indicator's pH range overlap with the quick pH change, that is good. Phenolphthalein pH range is 8 to 10, so it is not overlapping. 8 to 10 is not overlapping because a weak base pH will be around 9. It is not reached to 10. So methyl orange is suitable indicator, but phenolphthalein is not. So that is the correct answer. Right. I got the next one now. 12th one. Which of the following statement is true about all substances that form acidic solutions in water? See that they have bolded that word all. Which of the following statement is true about all substances that form acidic solutions in water? Now, acidic solutions in water, we consider HA, right, which is the acid. HA is the acid, right? We consider HA is the acid, right? Now, this HA reacts with water, so HA donate H plus to water, and it makes what? It makes H3O plus and A minus. Right. Right. Which of the following statement is true about all the substances that form acidic solutions in water? They are corrosive. They are liquids. They contain hydrogen atoms. They form H plus aqueous ions. The correct answer is they all make H plus aqueous ion because I have told you H3O plus is equal to H plus, right? So they are corrosive. We can't say that all are corrosive. Strong acids are corrosive. Strong acids are corrosive. Lactic acid, citric acid, like acids we eat in our daily life, they are not corrosive. They are liquids. We don't say that all the acids to be liquid. Some acidic gases there, you know that. They contains hydrogen atoms. Actually, hydrogen ions are released. Contain hydrogen atom is not that much true. If it was hydrogen ion release, that's okay. They form H plus ions, that is correct. So the answer for the 13th one is D. D is the answer for the 13th one. So now we go to the question number 14. Now we go to the question number 14. 14 has A, B, C, D parts. So I will show you the 14th question and we will read that. Question number 14 is this one. Select the correct pH for each of the following solutions. Nitric acid of concentration 2 moles per cubic decimeter, assuming it is fully dissociated. Sodium hydroxide concentration 2 moles per cubic decimeter, uh, using the KW. See, ethanoic acid concentration 2 moles per cubic decimeter, making usual assumptions. Right. So these parts are the next one. The mixture, uh, sorry, last one, the mixture formed when 25 of 2 moles per cubic decimeter sodium hydroxide solution is added to 50 of ethanoic acid, Ka is equal 1.7 into 10 to the power minus 5. Right. So the next one is, that's the question. So I guess you can, uh, you all read the question well. So now we will go to the points, right? So I guess you have read the question well. So now we go to the points, right? So now see this one. In the 14th A part, it is very similar to earlier question we discussed. So I am not going to discuss 14A and B because they are very similar questions to early discussed question. That's only time wasting. So I will go to the question number 14, part C. Ethanoic acid concentration 2 moles per cubic decimeter, making a usual assumption, that one. Right. So now They are talking about ethanoic acid. Ethanoic acid is this one, CH3 COOH. This is what the ethanoic acid is. You all know the formula of ethanoic acid, which is a weak acid. The concentration of the acid is given. The concentration, this acid's concentration is given as 2 moles per cubic decimeter. Concentration is given. Making the usual assumption, they have given the Ka. Now, if I consider the ethanoic acid is CH3COOH, aqueous, it dissociates to what? H plus ions and CH3COO minus aqueous. So I can write the Ka. Ka is equal, this concentration and this concentration equals because they have the equimolar concentration. Let it be x and x. So x to the power 2 divided by CH3COO H concentration. Ka is given, that is 1.7 into 10 to the power minus 5, x to the power 2, CH3COH concentration is given 2, right? Yeah, that is 2. So then now I will write x to the power 2 is equal 1.7 into 10 to the power minus 5 multiplied by 2. So x is equal square root of 1.7 into 10 to the power minus 5 into 2. So now I concern x value, right? So we can take x value if you have the calculator. You can find the value for the x, that is square root of 1.7 into 10 to the power 10 to the power minus 5 multiplied by 2. So it will be, if I made a calculation correctly, 0.0058, 0.0058 is that. So now you can find the pH. So then H plus concentration is equal actually 0.0058. So the pH is equal minus log H plus concentration. So the pH, if you find the pH for the 14th question, that will be 4.5 is the answer. Uh, so that's the way we do it. Right. And then the next one is the difficult one. So now we go to that. Right. That is question number 14, D part. The mixture formed when 25 of 2 moles per cubic decimeter sodium hydroxide solution is added to 50 of 2 moles per cubic decimeter ethanoic acid with the Ka is this one. Now you know this is buffer solution because normally they make the buffers when weak acid and their salts are made, right? So we write weak acid, weak acid, weak acid, we write Wa for the weak acid. Weak acid concentration, I want to find the weak acid moles. Weak acid moles, N is equal Cv, N is equal C. What the concentration of weak acid? 2. Concentration of weak acid is 2. Volume is how much? 50. 50. So convert to decimeters, divide by 1000. So then 2 into 50 divided by 1000 divided by 1000. So that is 2 into 50 divided by 1000, 0.1. How many moles there? 0.1 moles there. Then strong base is there, that is sodium hydroxide. The strong base, I write Sp. sodium hydroxide, N is equal Cv, right? N is equal C. C is what? What is C here? Concentration is 2. Volume is how much? 25 divided by 1000. So then it is N is equal to 2 into 25 divided by 1000. So then N is equal what? 0.05. Right. So now I can write this weak acid. My weak acid is CH3COOH plus sodium hydroxide. So it makes CH3COONA plus water. So this one, how much the mole? 0.1. Here, how much? 0.05. So how much of the salt produced? 0.05. Right? So how much of this remains? 0.05. So acid concentration 0.05. Salt concentration also 0.05. Right? Okay. Now that's the way it happens. Right. Now the next thing is the pH equation. The pH equation for the buffers. This is a buffer solution. Why? This is the combination of this one, CH3COOH and CH3COONA. So with the weak acid and the weak acid salt. So this is buffer. The buffer's pH can be found by the Henderson equation. The Henderson equation we write pH is equal pKa plus, sorry, pKa, yeah, pKa, pH is equal pKa plus log base acid concentration divided by salt concentration. Sorry, here it should be salt concentration and here it should be what? Acid concentration. So pH is equal, pKa value is given, I guess it is given Ka value. Yeah, Ka value is given. pKa, to find the pKa, you will take the minus log Ka, minus log Ka value is given 1.7 into 10 to the power minus 5 plus log value of salt concentration is what? 0.05, and then the acid concentration also what? Acid concentration also same. Acid concentration also same. Is how much? 0.05. So the calculator will give the value now. Uh, Now that is the way we do it. Right. So now I go to the question number 15. Right. I go to question number 15 now. Now I go to question number 15. So how do we solve that? The 15th question, right? In which of these reactions is the hydrogen sulfate behaving as the Bronsted-Lowry base? Right. So we see one by one. HSO4 minus HSO4 minus plus HSO4 minus plus H3O plus H3O plus gives H2SO4 plus water, right? They ask in which of these reactions hydrogen sulfate ion, I mean HSO4, behaving as a Bronsted-Lowry base. So here, see that here only one hydrogen, here only one hydrogen, right? Here there are two hydrogen if you notice. That means this is the one who donate H plus, this one. So this is acid and this act as what? Base. So they ask in which equation that HSO4 minus act as a base. In the first equation it act as a base. So the answer for that is A. Right. Answer for that is A. Right. So the next one is the solution of the hydrochloric acid has a pH 3. What is made when it is made 10 times more dilute, the pH is. Now we see that. Right. Now we see that a solution of hydrochloric acid has the pH 3. Right. So pH 3, pH is equal minus log H plus. pH is equal minus log H plus. So they have told you the pH value. They have given you the pH value. pH value is 3. Therefore, H plus is how much? How to find? We have to take an antilog of it. How do we take the antilog of that? 10 to the power minus 3. So H plus concentration is how much? 10 to the power minus 3. Right? So how do we find the antilog? Right? An antilog of 4.8, 10 to the power minus 4.8. Right. So like that. Okay. pH 3 means, so say that pH 1 means H plus concentration 1 into 10 to the power minus 1. pH 1 means, okay, pH is equal 1. pH is equal 2 means 1 into 10 to the power minus 2. pH is equal 3 means 1 into 10 to the power minus 3, like that. So I know the H plus concentration is 1 into 10 to the power minus 3. Now they are talking about HCl, like strong acid, H plus and Cl minus. Here 1 into 10 to the power minus 3 and here also 1 into 10 to the power minus 3. Right. So this is diluted 10 times. This is diluted 10 times. That means concentration of H plus decreased by 10 times. So new H plus concentration is 1 into 10 to the power minus 4. So we bring this new H plus concentration to pH expression. pH is equal what? pH is equal minus log H plus concentration. So the pH is equal minus log 1 into 10 to the power minus 4. Right. So then pH is equal what? 4. The new pH value is 4. Right. New pH value is 4. That is the answer for the 16th one. Right. This is very important. When they give the pH value directly, how to find H plus? Get the antilog. How to get antilog? 10 to the power minus that value is the antilog. Right. So I got the question number 17. In which reaction what is acting as a bounce to chloric acid? So this is easy one to know. So we are not going to discuss that. Which of the following solution has the lowest pH? That is good question. I will go to the 18th question. Which if which of the following solution has the lowest pH? Which of the following solution has the lowest pH? Right. Which of the following solution has the lowest pH? Now here we consider the solutions given. We consider the solutions given, right? For what are the solutions given? Hydrochloric acid. A solution A, HCl acid. Concentration how much? 0.01. 0.01. Right. B B HCl concentration is how much? 0.1. C ethanoic. D ethanoic. This ethanoic is a weak acid. Ethanoic is a weak acid. So they have the weakly releasing H plus. So they are not strong acids. They are weak acids. So the pH is high. Strong acid, pH less. So the best acid, lowest pH. Lowest pH means highest H plus. Right? Strong acids have very high H plus concentration, means very low pH. pH 0, strong acid, 1, 2, 3, like that acidity decreases. Right. So now this HCl gives little amount of H plus. This HCl gives more H plus. This one gives more H plus. Therefore, less less low pH. The low pH, that means good acid is the one who gives most amount of H plus. So who gives more H plus? The highest concentration one. So then the 18 B is the answer. Right. I go to the next one, the 19th one. I go to the next one, the 19th one. The question number 19. Right. An aqueous solution of ammonium chloride has a pH of less than 7 because we see that good question. That is a good question. How aqueous solution of ammonium chloride has a pH less than 7. How do we came to know something has a pH less than 7? Look at here. Normally the salts are there. Salts are, if there's a salt, that salt is a soluble salt, right? If there's a salt, the soluble is a soluble, the salt is a soluble salt. If the salt is a soluble salt, it's fully dissociated, fully ionized, completely dissolved, right? So similarly, now we are talking about ammonium chloride. See that we are talking about ammonium chloride, right? The ammonium chloride, all the ammonium salts are soluble, you know. Ammonium chloride highly soluble, so it makes what? NH4 plus and what? Cl minus A plus. Right? Okay. NH4 plus and Cl minus A plus. So that is how ammonium salt is. Now ammonium chloride dissolves like this. Now if this solution, if this beaker contains ammonium chloride, there are ammonium aqueous ions. Right. So when the ammonium ions are there, NH4 plus, in the presence of water, now what will happen? Ammonium ion act as a bronzochloric acid. It donates H plus. It donates H plus and makes what? H2O becomes H3O plus and then the ammonia. Like this way it happens. So see that 19th question, A answer we will read that ammonium ion donate protons. Yes, ammonium ion donate protons to water molecules, giving rise to the oxonium ion. H3O plus means it has another name for the H3O plus, that is called what? Oxonium. Oxonium means what? Uh, H3O plus ion is called oxonium ion. So the A is the answer for that. Right? A is the answer for that. Now we are in the 19th question. 20th onwards, the rest of the question we will discuss in another video.